Let's continue our discussion. Example 2. We'll look at the example 2. It's also in your textbook. If you go to the same page 278. A cyclist starts from a point. A cyclist starts from a point A and travels for 8 kilometers in the direction of 030 degrees. To B, and then 10 kilometers due north to C. Find the cyclist distance and bearing from A, its original position. Okay, let's look at how this will be tackled. First, we'll locate our A. Point A. The cycles traveled on a bearing of 030 degrees. That is from the North Pole, 10 and 30 degrees. And for a distance of 10 kilometers. Sorry, 8 kilometers. 8 kilometers, I beg your pardon. So 30 degrees, 8 kilometers. Let's 8 kilometers be somewhere here. You can do scale drawing. You can use scale, and like this 8 kilometers, you can draw 8 centimeters, and then at 10 kilometers, you draw 10 centimeters line, if you so wish. Then this will be our B. Position B. But if you're not doing scale drawing, when you draw the first line, all other line will be drawn subjected to the first line you have drawn. So like this, I'm not doing scale drawing. I can stretch my 8 kilometers to anywhere I want. But note that the other lines that you'll be drawing the diagram will be subjected to this one. So for example, if I drew my 8 kilometers, let me just give you an example. If I drew my 8 kilometers, come in, let me reposition this. Drew my 8 kilometers. Let me use a right to illustrate that. If I drew my 8 kilometers up to here and somewhere here, I should bear in mind that when I'm drawing the 10 kilometers will be longer than this one. In that case, the diagram is going to what? To require very large space. So when you are drawing the first one, you look at the figures that are there, then you just stretch it some length, and all other lines will be subjected to that one. Okay, now let's name the position. This is position B. Then at B, the person traveled due north. B, 10 kilometers, so that one should be longer than my previous line, to a place called C. So this will be my C. Let me name that place C. Then I enclose the triangle. So I have my triangle ABC. Now, this is where this is the diagram. Then let's now indicate our angles and our dimensions. Is very, very much important, as I told you. If we're using scale drawing, even though you'll be drawing maybe 8 centimeters for this line, you don't write 8 centimeters, so write 8 kilometers. Take note of that. if you want to use scale drawing, you draw the diagram to scale, but you write the correct measurement. For example, if you measured, use scale drawing, and you measured here 8 kilometers, you use 8 centimeters, and then here 10 centimeters for the 8 kilometers, but you don't write 10 centimeters, you write the 8 kilometers. Okay, so here will be 10 centimeters, sorry, 10 kilometers. 10 kilometers. The only angle provided was the 30 degrees. Let's indicate the 30 degrees. 30 degrees. 30 degrees. These are 30 degrees. 30 degrees. You'll be using your hand, so you will not be fumbling like how I'm using my mouse, my computer mouse here. So this is a diagram. You see my angles, the angle that I have been shown. Always when you draw an angle, you use this arc, brace back arc, to show actually where you meant. Okay. Now the question is asking us to find the distance between the final position and A, the final position and A, each previous position. Let's analyze the interior angles. You will see that with this triangle, this angle here is 90 degrees, and this angle here is 60 degrees. 60 degrees because if from here up to this line is 30, the space here will be 60 degrees. So, and this 60 degrees will alternate to this place. This 60 degrees will alternate to this place. This will make this angle also 60. So the interior angle here is more than 90 degrees. It's an obtuse. Then when you come to this side of the triangle, the whole of this place is 30. It implies this place is less than 30. Okay, it's less than 30. And even in a triangle, so far as one of the angle is obtuse, none of the interior angles will be a right angle. So far as one of the angle, the triangle, is obtuse, none of the interior angles will be 90 degrees. The rest will be acute. So it implies that this, our triangle ABC, is not a right angle triangle. So we cannot apply the trigonometry, the basic trig ratios on this triangle, and neither can we apply the Pythagoras theorem on this triangle. So there are two ways you can do that. You can do some projections, some extensions on the diagram, or you can use the cosine rule and the sine rule, of which I'll teach you as the lesson progresses. If I'm not able to cover it in these tutorials, when we come back next time, those doing EMAS, I couldn't do the tutorials for the EMAS, and I'll be doing the tutorials within the vacation on trigonometry, whereby I'll discuss some of this and upload them to YouTube, so that if those who can afford data will watch the tutorial online, on YouTube. So, but those doing commerce who will not be watching, when we are come back to school, I'll have an appropriate time to take you through the cosine rule and then the sine rule, in case I'm not able to cover it in this tutorial. So with this question, I'm going to use the projection approach. I will do some extensions on my diagram, and this is when I will extend. Let me use a different color. Green will do. I will extend the eastern part of my A. Good. Then I will extend my southern part of my B. Good. Good. So it will make this place 90 degrees. 90 degrees. Good. Good. as I've said earlier on, we know that this angle is 60 degrees. Let's put it there. 60 degrees. 60 degrees. 60 degrees. Let me enclose that space so that you see which area I'm talking about. This is 60 degrees. Now, let me call this position D. My new position D. Good. Now you can see ADC taking the whole shape. It's a right angle triangle because these two lines, anytime the east-west line intersect the north-south line, an angle of 90 degrees is formed. They are always perpendicular to each other. So the whole shape here now becomes a right angle triangle. Now what we are left is to find the distance AC. The distance AC. In order to find the distance AC, we are going to use Pythagoras theorem. And Pythagoras theorem, this will be the hypotenuse. So the square of the side plus the square of the side will give us the square of the hypotenuse. But unfortunately, this side is not known. So we have to calculate for this side. So I am extracting this triangle out. Right angle triangle out. Let me extract that one out. Good. So that is it. Or better still, we can. So I've extracted, instead of drawing a new one, I've just extracted that portion of the diagram out so that it will stand alone, so that you can see what we are coming to discuss very well. So this is this portion of the diagram. I want to find AD, the distance AD, by using trigonometry ratio. Now note that this is a right angle triangle. Our reference acute angle is 60 degrees. In that case, this is my adjacent, and this is my opposite, and this is the hypotenuse. Hypotenuse is always constant, but the adjacent and the opposite always depend on the acute angle in reference to. So this is the angle in reference to, so we have the adjacent to be this place. Remember the basic trigonometry ratio. Anytime you are confused, just go and write it down. So K2. So which of we are looking for the adjacent, and we have the hypotenuse. So which of the ratios do you think is applicable? We can't use sine because sine is talking about opposite. We are not looking for the opposite now. We are interested in the adjacent. Toa is opposite of adjacent. We are not interested in the opposite now. We are interested in only the adjacent. So it's better we pick cos, which is adjacent over hypotenuse, to enable us to calculate for our adjacent. So I am going to label my adjacent and my hypotenuse, my adjacent and my opposite, with variables x and y. So let's put them there. Let's call the adjacent x for the meantime, and call the opposite y. Cos theta, the formula says adjacent over hypotenuse. So we are come to place the value of our adjacent here, and our hypotenuse 8 kilometers over here. Then our theta over here. Good. So our cos 60 degrees is equal to x over 8. We are looking for x, so we cross multiply. This is over 1. to multiply the x, and the a to multiply the cos. So we are going to have this over 1, so multiplying the x will give us x, then the a to multiply the cos 60. Let me just write 8 cos 60 degrees, 8 cos 60 degrees, 8 cos 60 degrees. So we are going to find the value of 8 cos 60 degrees. Just press on the calculator 8 cos 60. This is how it will be done. You press 8 here, press the cos. The moment you press cos, it will give the open bracket will automatically appear. You punch your 60, you close the bracket, you press the equal sign. 8 cos, the open bracket will appear. You press the 60. The moment you press the cos, it will come with an open bracket. Take note of that. When you press the cos, it will come with an open bracket. So all that you need to do is to enter the 60, then you close the bracket and press your equal sign. The answer will appear. Remember, do not go and press shift before cos like how we did with the previous tutorials. That one will bring you cos inverse. We are not looking for cos inverse. We are looking for cos itself. So just press cos. Don't go and press shift before cos. So I'm repeating again. Press 8, press cos, then you press 60 for the 60, close bracket, then you press the equal sign, and your answer will appear on the screen. If you indeed press 8 cos 60 and your calculator mode is correct, you are going to get 4 kilometers. 4 kilometers. 8 cos 60 is equal to 4 kilometers. Note that cos 60 is half, is 0.5. That's why our x is 8 kilometers. So now we have now calculated for the value of this side. So remember, our attempt is to find out the length AC, and it's going to be this side square plus the full side here square is equal to the side square. This side, this DC, we know the value of only ACB. So you're going to calculate for the value of BD here, so that we can get a full length of this side of our triangle. Good. 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 Now, let's go to the next stage of our discussion. We are going to solve for the other side. Y. Y is opposite. So now that we know the adjacent, we know the hypotenuse, we can use any of the trig ratios. I am going to use sine. Sine is opposite over hypotenuse. The formula for sine theta is equal to opposite over hypotenuse. Our opposite is y, and our hypotenuse is still 8, and our theta in this case is 60 degrees. Sine 60 degrees is equal to y over 8. I have placed the value of the theta and the value of the opposite, which is y we don't know, and the value of the hypotenuse in the appropriate position. Similarly, we'll do cross multiplication. So when we multiply 1 by y, the denominator here is y, we'll get y. The 1, we multiply 1 by y, we get 1. We shall have 8 sine 60 degrees. We'll have to press on our calculator to get the value of 8 sine 60. In fact, I don't need to tell you how to press 8 sine 60, because I think now you've mastered it. But let me teach you for the last time. You press sine direct. Press 8 first. Press sine. Press 60. Close bracket. Press the equal sign. 8 sine 60. Press 8. Press the sine. type in your 60, close the bracket, press the equal sign, and always make sure that your calculator is in degree mode. I have already taught you how to convert to change the calculator to degree mode. So let's proceed on. And 8 signed 60 will give us 6.94 kilometers. That is correct to 2 decimal place. Correct to 2 decimal place. So our y is 6.94 kilometers. 6.92, sorry. It is 6.92 kilometers. 93 kilometers. Good. 6.93 kilometers. 6.93 kilometers. 6.93 kilometers. 6.93 kilometers. Now, so the full distance from here to here, which is BD. Now, our BD, the dimension BD, sorry, CD, it's supposed to be CD. C from C up to D. CD will be equal to 6.93 plus 10 kilometers, and we are going to get 16.93 kilometers. 16.93 kilometers for the total distance. Okay, so that is that. Now let's look at how to define our AC. I want to sketch a right angle triangle. Now I'll first sketch the diagram. I've just extracted so that you will see what is happening. I've extracted the ADC out so that it stands alone. We are looking for AC. We are going to use Pythagoras theorem. Let's call the AC P, or any other variable. I call it P. On that note, we can write P square. Not the P square, the musician. This is P square as regards to our question. P square is equal to 4 square. 4 square plus 16.93 square. I hope you can solve for the value of P. I'm waiting for you to tell me the answer. I hope you had what I also got. I hope he had 17.4 kilometers. 17.4 kilometers. We had 17.4 kilometers. So that is it for finding AC. 2 degrees.